So our next lesson will be about your superposition theorem. Superposition. Guys, ano nga ba itong superposition theorem? Dali lang to guys. Itong superposition theorem states that it is the algebraic sum of the voltages across a linear circuit. That is, take note, that is acquired or acted upon by independent voltage or current sources. So pag sinabi nating independent sources, these are the sources or your current in your voltage source that are not dependent to the voltage of a passive element. Okay? That is your superposition principle. Ibig sabihin yan, ito-turn off mo yung lahat ng mga voltages or current source that are independent, and then magtitira ka lang ng isa. Sabi nun, isa-isahin mong i-turn off yung voltages or current sources that is present in the circuit. So after that, you will solve for their impact to the current that is in the circuit. So pag kinuha mo yung current nun, so isa-isahin mo siya. So if there are 5 sources, independent voltage or current sources, therefore there will be 5 circuit analysis, because you will analyze the circuit with each sources. Okay? Ang kailangan mo lang tandaan in superposition theorem is that if there is what you call your voltage source. So ito yung voltage source natin, di ba? And it would be shorted. Pag sinabi natin shorted, magiging isang line lang yan. If turned off. And number 2 is that we have our current sources. Pag may current source tayo, take note, this is independent current source. Okay? So magiging open. Sabihin ng open is that magiging ganito lang siya. Okay? So these are your symbol. Yeah. This is the symbol at opening and turn offing your current sources. Okay? Bago natin simulan yung superposition theorem, no? So I will draw. Let's say we have a current. Let's have a circuit, positive and negative. Let's say this is V. And then let's say we have a resistor R1. And then another resistor R2. And then a current source I. Then another resistor. Okay? If we will analyze the, let's say, your Vx, positive ni Vx at R1, so ang sinasabi ko kanina dito is that we will analyze them in 2 sources. So at source 1, so sabihin natin analyze natin siya at voltage at V. So therefore ito lang yung on natin. So magiging ganito siya. So as I have said, so this will be your V, and then will be your R1, and then your positive negative Vx. And then take note that since yung V, yung ina-analyze natin, gagawin natin open yan. Since it is a current source, take note, pag current source, magiging open siya. And then this will be your R2 syempre, and then your R3, right? And then you will analyze the Vx with respect to this V. Okay, and then so pag may Vx ka na at V, Vx at V, okay, and then meron kang analysis B, is that we will analyze it at current source. Pag in-analyze natin yan at current source, so ang gagawin natin is that, so we have, magiging shorted naman to, i-short natin to. Okay, so we have our R1, R2. Okay, so we have positive, negative Vx, and then our current source, which will analyze your Vx, and this will be your R3. So meron tayong Vx double prime. Sabihin natin nga Vx prime to. Vx double ba? Prime naman yun at I source. Therefore, we will get the total Vx. So Vx total, which is equal to the voltage at Vx, which is equal to your Vx prime, which means that it is the voltage that is given by your voltage V plus our Vx double prime, which means the voltage that is given by our current source. So this will be your total. Okay, so mapansin nyo, natukoy ko lahat yung definition ng superposition natin. It is the sum of the voltages across a circuit that is acted upon by independent sources. Okay, isang i-analyze natin yung circuit. So let's have an example. Okay, so our example will be your practice problem. Okay, so let's have a 25 volt source. This is a dependent source, independent source, positive, negative, 25 volts, and then we have our 20 ohm, and then we have our Vx, and a current source 5 ampere, independent yan, and then we have our 4 ohm, and then we have our dependent, okay, dependent current source, which is a voltage controlled. Okay, so take note that our Vx is in this terminal, positive, negative. Okay, that is our Vx. Okay, first step is that since this is a superposition, solve for Vx using superposition. Solve for Vx using superposition. Okay, actually you can solve it using your mesh and nodal analysis. Particularly, pwede mo rin siyang i-analyze at your superposition. Pag sinasabi kasi natin superposition is that we will analyze the problem with its source. So, pwede rin natin gamitin yung mesh and nodal analysis nyo pag natanggalan natin yung ibang sources. Okay, so we will analyze your Vx at 25 volts. So at 25 volt source, analyzing at 25 volt source, which means papatayin natin yung 5 ampere. So take note, in superposition, pag independent current source yan, pag pinatayin natin, magiging open siya, and this will be the symbol. Right? So we will have a new circuit diagram, so which is your positive, negative, 25 volts. Then you have our 20 ohm, and then yung Vx natin. Since yung Vx natin is a current source na papatayin natin because we will analyze it at our voltage source, so mag-open yan. Okay, open siya. Open, which means walang current na dadaan dyan, pero may voltahe yan. Okay, and then we have our 4 ohm, 4 ohm, and then we have our dependent source, current source, Vx, which is equal to 0.1 Vx. Ayan. So, ano mapapansin nyo, we can actually solve for Vx immediately because this voltage source, which is parallel to 4 ohm, so therefore this is also Vx. Tama? So therefore, meron tayong isang node. Let's say this will be your node Vx. Okay, I may say, or I may use my current or my nodal analysis. Okay, so if I have my nodal analysis, let's say this will be my I1, and then this will be my I4 because it is flowing into your I4, and then this will be my I3. So pwede na akong hindi mag-assume ng direction ng current, gagamitin ko lang yung direction ng current ng dependent source natin. Okay, KCL at node Vx. KCL at node Vx. So we'll have a current entering to your node, which is your I1. So sir, but hindi mo na isasaling node na yan. Hindi na. Why? Because basically it is already open. Ibig sabihin pag open dyan, so basically pwede natin sabihin na wala yan. Yan. But take note that there is also voltage in the terminal. Okay, so pwede natin tanggalin yan. So this will be our Vx, because this Vx is in parallel with this Vx, therefore they are the same. So considering our Vx, so we have, let's say that this will be your Vx, KCL at node Vx. So since this is at 25 volts, so lalagay ko dito Vx at 25 para hindi natin makalimutan that it is your Vx at 25 volts. So we have our I1 entering to your node Vx 25, and then your I4 going out to your node Vx 25, and then your positive because it is entering your dependent current source, which is a voltage dependent current source. 0 plus 0.1 Vx, it is entering to your node via conservation of charges, it is equal to 0. But what is your I1? Take note that in order to get your I1, so magagawa muna tayo ng datum in order to set our zero potential. So our I1 is basically equal to, so 25 minus Vx from higher to lower potential divided by our 20 ohm. It's our I1. And then our I2, our I4 is basically equal to Vx over 4. Okay, so do we need to still find for the Vx of this one? No, because it is already well represented in our problem. It's already represented in our problem. So we have substituting substituting I1 and I4. Okay, so let us substitute your I1 and I4. So we have 25 minus Vx over 20 plus Vx all over 4 plus 0.1 Vx is equal to 0. So we have 25 over 20 minus Vx over 20 plus Vx over 4 plus 0.1 Vx equals 0. So we'll have negative. So lalabas natin lahat ng Vx mo. Vx multiplied by negative 1 over 20 plus 1 over 4 plus 0.1, which is equal to our negative 25 over 20. So tama ba? Okay, tama yan, di ba? So after that, we will solve for your value of your Vx. So we have negative 1 over 20 plus our 1/4 plus our 0.1. So we have a value equal to 0.3. Okay, take note that this Vx here is going out the node, diba? Ba't siya naging add, diba? Going out siya. So gagawin natin ito, it must be negative, right? Negative, kasi nga it is going out the node. This must be I1, negative I4. So going out, so this must be negative. So this will be negative. Okay, so we have a value equal to negative Vx minus 1 over 20. Okay, Vx multiplied by our negative 1/5, which is equal to negative 25 over 20. So consider whatever equation you were in, tuturuan ka ng equation mo in our nodal analysis. Okay, so we have our Vx, which is equal to negative 1/5, so negative 25 over 20 divided by our negative 1/5. Therefore we have a value equal to our Vx at 25. So at 25, huwag natin kakalimutan yan. 25 at 25 at 25. We have our Vx at 25 volts, which is equal to your 6.25 volts. That is your Vx at 25 volts. Okay, analyzing this circuit at 5 ampere. Analyzing at 5 ampere. So we have another circuit diagram. So since this is a voltage source, so anong gagawin natin? Magiging short siya, shorted. So straight, naging straight lang siya. So isi-short natin siya. Yan. Yan. So we have, wala yan. Okay, so we'll have this 20 ohm, and then your 5 ampere, and then we have our 4 ohms, and then another 0.1 Vx. Mapapansin nyo, hindi natin pinapatay ang dependent source, because actually this dependent source does not provide power energy alone. Ang nagpro-provide lang is your independent source, because your dependent source will be dependent on the passive element wherein it was or it is dependent to. So this will be our positive and negative Vx. So positive, negative Vx. Okay, ganun ba rin siya? This Vx is in parallel with this 4 ohm. But actually, so mas maganda siguro pag black na lang, no? So maganda siyang tingnan pa rin. Okay. Okay. Actually, this node is just one node. Itong node na to. Itong node na to. Buong node lang yan. Let's say this will be our node Vx5. It means it is a Vx at 5 ampere. Okay. KCL at node Vx5. KCL at node Vx5. So we have our currents, assumption of current. So dito ako mag-assume since current source na to, ito na lang yung assume natin at 20 ohms. So this will be my current at 20 ohms, and then pababa sa 4 ohms. Okay, so we have a negative, let's say this will be my I20 and this will be my I4. So we'll have a current going out to node. We have negative I20 ohm plus our 5 ampere. It is going into our Vx5, and then minus I4. It's going out the node plus 0.1 Vx equals 0. Take note that our I20 is equal to Vx5. So Vx5 divided by 20. So lalagyan natin siya ng datum. This is KCL or your nodal analysis. So bakit? Kasi magiging Vx minus 0, di ba? Kasi yung datum natin na yung 0. So Vx minus 0 is just Vx5 over 20. Vx5 over 20. That is our I20. And our I4 is just equal to Vx5 all over 4. Okay? So let us substitute. So we have I20 substituting the values. We have our negative Vx5 over 20 plus 5 minus Vx5 all over 4 plus 0.1 Vx5 equals 0. Okay, so pagsama-samahin natin lahat ng may Vx5, so we have Vx5, factoring out your Vx5, we have 1 over 20 negative minus 1/4 plus 0.1 is equal to negative 5. Kasi transpose natin dito yan. Okay, next is that after that, so we have negative 1 over 20 minus 1 over 4 plus 0.1. So we have Vx5 is equal to negative 1 over 5 Vx5, which is equal to negative 5. Therefore our Vx5 is equal to 25 volts. How will we solve the total voltage? The total voltage then is V total or your Vx total is equal to Vx25 plus Vx5, which is basically equal to 6.25 plus 25. Sir, mas madali naman yung nodal analysis kaysa dyan. Actually, you cannot yet appreciate the beauty of superposition because you are analyzing a DC circuit which has no frequency. But if there will be a AC circuit wherein there will be different frequencies, therefore you will see that it is the best solution into the problem, because you cannot add voltages or currents with different frequencies. Mahirap analyze yun, guys. So with the help of your superposition, you can analyze that one. It is very easy, or it is your nodal analysis is easier because, or your mesh analysis is easier because you are dealing with DC circuits. But if you have different frequencies, the suggested or the best solution will be your superposition. So this is 31.25 volts. Actually, we can analyze it already using our nodal analysis. To prove the answer is 31.25 volts, so we will use nodal analysis. So using nodal analysis for proof, okay, proof using nodal analysis. Nodal analysis. Okay, so take note that it is just one node. Isang node lang to, di ba? Kasi nakaparal lang yan, isang node lang yan. Kasi pag dinowing mo yan, parang ganito lang to, di ba? Magiging ganyan lang siya. Then meron kang ground, punta sa ground. Okay, parang magiging ganyan lang yung circuit na itsura niya. So therefore, this is just one node. Okay, so we have our I1. Let's say this will be my I1. Okay, so gamit tayo ng black. Gamitin natin yung katabi mo, yung black. Yan. So we have this will be my I1 or my I25 Vx, means from 25 volts to Vx, which means that my 25 volts is my higher potential and my Vx is my lower potential. And then this will be my I4 and then my 25 Vx. Okay, so this will be my ground. Okay, so proof using nodal analysis, we have our I1, which is basically equal to, or I1 is equal to 25 minus Vx all over 20. Our I4 is equal to Vx over 4. Okay, so we have KCL at Vx, KCL at node Vx at node Vx. So we have our 25, so I25 Vx is going into your node, so I25 Vx going into your node, plus your 5 amperes is also going to your node, and then our 4 ohms is going out the node, minus I4, and then your dependent source is going into the node, which is 0.1 Vx. Okay, so we have our I25, so we have 25 minus Vx over 20 plus 5 minus Vx over 4 plus 0.1 Vx is equal to 0. So we'll have a value equal to 25 over 20 minus Vx over 20 plus 5 minus Vx over 4 plus 0.1 Vx equals 0. So combining all the terms with Vx, so we have Vx multiplied by negative 1 over 20 plus negative 1 over 4 plus 0.1 is equal to negative 25 over 20 minus 5. So napansin nyo, pag in-add yung dalawang to, yung equations lang nila, makukuha nyo to, diba? So we have our negative 1 over 20 plus negative 1/4 plus 0.1. So we have negative 1 over 5 Vx, which is also equal to 25 over 20 plus 5, which is equal to 6.25, negative 6.25. Therefore Vx is equal to negative 6.25 multiplied by negative 5. We have times 5, we have our 31.25 volts. So as I have said, the beauty of superposition theorem is not on DC analysis but in AC analysis with different frequencies. So you see that they are similar. Kahit ano pang gawin mo yan, kahit mag-source transform ka pa, dapat parehas yung makukuha mo sagot. Okay?